Today we're going to talk about 2.6, proving statements about angles. Alright, so this is all going to be just basically proofs, and everything's about angles. From here on out, every time we have a theorem, you can notice there's a theorem, here's another one down here. Every time we have a theorem, that's not a theorem, but every time we have a theorem, we're going to prove it. Alright, we cannot use theorems until we have proved theorems. Postulates, we don't need to prove. Definitions, we don't need to prove. Okay, but the theorems we do. So we're going to start off first of all with some properties. These are properties, and properties are like theorems, like postulates and definitions. You do not have to prove them. So you've got the reflexive property. Now this is real similar to what we were doing the other day with the algebra. The algebra said that A equaled A. Well, for angles, the reflexive property says the measure of angle A equals the measure of angle A. Alright, so that is real similar to what we were doing the other day. From that, since the measures are equal, then they are also congruent. So when we have this step in a proof, then we might add this step, or vice versa. If we have this step in the proof, then this might be our next step. So from one, we get the other. The symmetric property is very similar to the one that we had the other day. If measure of angle A equals measure of angle B, then the measure of angle B equals the measure of angle A. So that's just exactly like the symmetric property we had the other day. And if angle A is congruent to angle B, then angle B is congruent to... This is just saying the same thing, except saying it with a congruent statement instead. And of course the transitive property, one of our favorites. Remember the last time it was if A equals B and B equals C, then A equals C. Well, here we go again. The measure of angle A equals the measure of angle B, and the measure of angle B equals the measure of angle C, then the measure of angle A equals the measure of angle C. So it's similar. Here's the congruent statements for that. Similar from what we were doing the other day. Alright, so this is all just applying to angles this time instead of actual numbers. So the next one I want to talk about then is the definition of congruent angles. Alright, the definition of congruent angles. Don't forget to put today's date up here in your notes. Today's date, so that way you have it documented on what day you're doing this. Alright, the definition of congruent angles, all it says is that two angles that have the same measure. Definition of congruence. So if the angles are congruent, then by definition we know that their angle measurements are equal. So the next thing we're going to talk about is the right angle congruence theorem. The right angle congruence theorem. Alright, and basically all the right angle congruence theorem says is that all right angles are congruent. All right angles are congruent. Well, we already knew that. We already knew that a 90-degree angle is a 90-degree angle, and they're going to be equal to each other, but we're going to prove that so that way we can continue using it all semester, all year long. Alright, so we're going to prove that. The given information in this proof is that angle 1 and angle 2 are right angles. So write that down. And we're going to prove that angle 1 is congruent to angle 2. So here are your statements, and here are your reasons. Your statements and your reasons. Alright, so again, we're going to prove, I didn't write 2 right there. So we've given that we've got angle 1 and angle 2 are right angles. We're going to prove that they are equal. So first part of the statement is the given. Angle 1 and angle 2 are right angles. That's given. Then step number 2, since we know they're right angles, most of you know what I'm thinking here. If they're right angles, we know they equal 90 degrees. So we'll say that. Measure of angle 1 equals 90, and the measure of angle 2 equals 90. That's just a definition of a right angle. So that's exactly what an angle is. So since they're both 90s, then their measures must be equal. Number 3, measure of angle 1 must equal the measure of angle 2. That's just a little bit of substitution there. Since they're both the same, then they're both equal. And so therefore, step number 4, remember what we're trying to prove right here. This is going to be always our last statement. Angle 1 is congruent to angle 2 by definition of congruence. Went from measure to congruent statement. Every time you go from measure to congruent statement, that's definition of congruence. Oh, there we go. I'll put it up there a little so you can see it better. All right, so the next one, the congruent supplements theorem. Congruent supplements theorem is our next one. All right, this one's kind of long, so we're going to have to write small. It says if two angles are supplementary to the same angle, if two angles are supplementary to the same angle, if two angles are supplementary to the same angles or congruent angles, then they are congruent. Alright, if two angles are supplementary to the same angles or they're congruent angles, then they are congruent. Alright, so here we go. We're going to try to prove this. You're given angle 1 and angle 2 are supplementary. Okay, and we are also given that angle 3 and angle 4 are supplementary. Okay, so we've got both of those. And we're going to be given also that angle 1 is congruent to angle 4. Angle 1 is congruent to angle 4. What we want to do is we want to prove that angle 2 is congruent to angle 3. Prove that angle 2 is congruent to angle 3. Alright, so here we go. We're going to have to write really small because this is a lot. Got your statements and your reasons. Alright, number 1, just to save space, of course, is all you're given. So I'm just going to write C above there so we can save some space because I'm running out of room. So angle 1 and angle 2 are supplementary, angle 3 and angle 4 are supplementary, angle 1 is congruent to angle 4. Alright, so since we know they're supplementary, hopefully you're thinking what I'm thinking, that when you add those together, you would get 180. So number 2, the measure of angle 1 plus the measure of angle 2 equals 180. The measure of angle 3 plus the measure of angle 4 equals 180. That's just the definition of supplementary angles. That's just the way they work. Okay, they equal 180. Now since they both equal 180, then they must equal each other. Number 3. The measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. Alright, that's just a little bit of substitution. So easy enough right there. Now, what do you know about 1 and 4? 1 and 4 are congruent. So you know their measures are equal. Alright, so step 4, the measure of angle 2 must be equal to the measure of angle 3 by subtraction property of equality, because what we're doing is subtracting the measure of angle 1 off of both sides. And then we have 2 is equal to 3. Now, this probably should be a step 5 here, and I'm going to run out of room, so I'm going to write it right here, that angle 2 is congruent to angle 3. Okay, because you remember, we're trying to prove the congruence, not that their measures are equal. So we really need to add that last statement, and then that would be definition of congruence. Alright, so I apologize for that. That got, let me push that up a little bit so you can see what I did. I got a little hairy scary right there at the end. But anyway, hopefully you were able to understand pretty much most of that. Alright, let's talk about the congruent complements theorem. The congruent complements theorem. Honestly, it's going to be very similar to this one we just did, the congruent supplements theorem. So honestly, the proof's just very similar. Very, very similar. I don't see a good reason for me to spend time doing it with you right now. Not to mention the fact that it's number 18. The proof of that is number 18 in your homework. Let's just go ahead and definitely write the statement down here, though, for our notes. If two angles are complementary, remember that means they add up to 90 degrees. If two angles are complementary to the same angles, then they are congruent. So when you get to number 18, proof, we'll just write this down so you don't forget, number 18 in the homework, then you can come back here and you can check your congruent supplements theorem proof, and it's very, very similar. Alright, so let's move on. The linear pair postulate. The linear pair postulate. You did hear me say postulate, so that's good news. So we will not have to prove this one, so let's go ahead and write it down. If two angles form a linear pair, if two angles form a linear pair, then they are supplementary. If two angles form a linear pair, then they are supplementary. So if two angles form a linear pair, that, of course, this is a true statement, but what I'm wondering is what about the converse of that statement? If two angles are supplementary, then they form a linear pair. Well, that is actually false. The converse of that is a false statement, because just because two angles are supplementary doesn't mean they're going to form a linear pair. Remember, this is what a linear pair looks like. So like this might be 100 degrees and this might be 70 degrees. So, but I may have a couple angles, say like this one, which is, I don't know, let's call that 110 degrees. But then I have one over here that's, say, 70 degrees. Those are supplementary, but they're not a linear pair. So just keep that in mind. But if we ever do have a linear pair, it's kind of nice that you can go ahead and say that they're supplementary. So in other words, you can go ahead and say that the measure of angle 1 plus the measure of angle 2 is equal to 180, thanks to the linear pair postulate. All right? Okay, the next one is the vertical angles theorem. The vertical angles theorem basically says that vertical angles are congruent. Vertical angles are congruent. Alright, well, we've already talked about how vertical angles are congruent, but lo and behold, it's a theorem, so we're going to have to prove it. So I'm going to give you some information, the given information, and you're going to need a picture. So let's draw two lines. like this. Why don't we call this 5, 6, and 7? Angle 5, angle 6, and angle 7. And you're given that angle 5 and angle 6 are a linear pair. And you're also given that angle 6 and 7 are a linear pair. Angle 6 and angle 7 are a linear pair. So what you're going to prove is that angle 5 is congruent to angle 7. We're proving these vertical angles are congruent. Alright, and we can definitely see that they're a linear pair right there. Oh, I'm so sorry. Let me move that up for you a little. Alright. I'm going to have to need a cameraman is what I need so I can keep the page going. So if you need to pause that and write that down, do so. Okay, I'm going to go ahead and print the proof over here since there's not really enough space down there. We'll have our statements and our reasons. Alright, so number 1, of course, is given. Alright, I'm not going to write all that down again. We'll write C left. Okay, given information. In other words, angle 5 and angle 6 are a linear pair. Angle 6 and angle 7 are a linear pair. Number 2, if they are a linear pair, then angle 5 and angle 6 are supplementary. Angle 6 and angle 7 are supplementary. And that is because they are a linear pair. It's basically the linear pair postulate that says if you have a linear pair, then they're supplementary. So statement 3 is going to say that angle 5 is congruent to angle 7. Yeah, it's that easy. Therefore, we're done. Angle 5 is congruent to angle 7 because of the handy-dandy congruent supplements theorem that we proved up here that said angles that are supplementary to the same angle. Alright, so that is the congruent supplements theorem. We already wrote that above. And that's pretty much all I have for you this time. So bring this to class with you and we'll use it in some homework. See you later.